normalizer of a subset X in a group G. Let X be a subset of a group G. The set consists those elements of the group G which permute with the set X is called the normalizer of the subset X in a group G and is denoted by normalizer of the set X in a group G. And symbolically we can write it as the normalizer of the subset X in a group G is the set consists those elements A belong to the group G such that AX is equal to XA. That is, the element A is permute with the set X. For example, the clean 4 group G generated by two element A, B such that when we operate the element A with the element B which is equal to an element C of the group G such that when we operate the element A 2 times with itself, the element B 2 times with itself and the element C 2 times with itself is equal to an identity element E of the group G. The table of the clean 4 group is as below. That is E is an element of the group G. A, B and C are the element of the group G. We operate each element of the group G with itself which gives an element. These are the result which are the element of the group G. These elements satisfy all the condition of the group. That is the multiplication is a binary operator on the set G, and because when we operate each element of G with the element of the set G, the result all these results are again the element of the set G. Therefore the multiplication is a binary operator on the set G, and the element E is an identity element of G. Also the element A is the inverse of itself, the element B is the inverse of itself, the element C is also the inverse of itself. That is, the inverse of each element of G is contained in the set G. Also the element A is when we operate if we check the associative property, then the associative property satisfy in the element of the set G. Therefore all the condition of the group is satisfied in the set G. Therefore according to the definition of the group, the set G is a group with respect to the given binary operator. Now also from the observation that when we operate the element A to the element B, when we operate the element B A to the element B, the result is equal to an element C. Also when we operate the element B to the element A, when we operate the element B to the element A, the result is again an element C. Therefore the commutative property is satisfied. Also when we operate the element A to the element C, when we operate the element A to the element C, the result is equal to an element B. And when we operate the element C to the element A, the result is also equal to an element B. That is the commutative property with respect to the given binary operator is satisfied in the elements of this set. Also when we operate the element B to the element C, when we operate the element B to the element C, the result is equal to an element A. And when we operate the element C to the element B, the result is equal to an element A. So commutative property with respect to the binary operator is satisfied in the elements of this set, in the elements of this group. For example, let X be a subset of the group G. For an element A belong to the group G, AX is equal to, we operate the element A to each element of the set X, which is equal to, when we operate the element A to the element A, which is equal to A square is an identity element. A square according to the above table is equal to an identity element E of the group G, and operate the element A to the element B, which is equal to operate the element A to the element B, the result is equal to an element C. Operate the element A to the element C, operate the element A to the element C, the result is equal to an element B. Now again operate the element A to the right side, from the right side to the each element of the set X, which is equal to operate the element A to the element A, which is equal to A square. When we operate the element A to the element A, the result is equal to an identity element, which is equal to, which is denoted by E. And when we operate the element B to the element A, the element B to the element A, the result is equal to an element C. Operate the element A to the right, from the right side to with the element C of the set X, that is CA. The result is equal to an element B. CA is equal to an element B, which are the same element, is calculated in the set AX. These two sets are the subset of each other, therefore this set is equal to the set AX. Therefore we can decide that the element A is an element of the normalizer of the set X in a group G.